Why is electrical power transmitted at high voltage? Electrical power is transmitted at high voltage to reduce the transmission current for a given amount of power. Since transmission loss is proportional to the square of the current, I squared R loss, increasing the transmission voltage significantly reduces power losses, conductor size, and overall transmission cost. Why are stranded conductors used instead of solid conductors? Stranded conductors consist of several small wires twisted together. They are preferred because they provide greater flexibility, better mechanical strength, easier installation, reduced skin effect, improved reliability against mechanical stresses. What are bundle conductors and why are they used? A bundle conductor consists of two or more conductors connected electrically in parallel and separated by spacer dampers. They are mainly used in extra high voltage EHV transmission systems to reduce corona loss, reduce radio interference, reduce audible noise, increase power transfer capability, lower surge impedance. What is the skin effect? Skin effect is the tendency of alternating current to flow mainly near the outer surface of a conductor rather than uniformly throughout its cross section. The skin effect increases with frequency, conductor diameter, magnetic permeability. The result is an increase in the effective resistance of the conductor. What is the proximity effect? The proximity effect is the non-uniform distribution of current in a conductor due to the magnetic field produced by nearby conductors carrying current. This effect increases the effective resistance and power loss in transmission lines. What is corona in transmission lines? Corona is the ionization of air surrounding a high voltage conductor when the electric field intensity exceeds the dielectric strength of air. It appears as a faint violet glow accompanied by a hissing sound. Effects of corona: power loss, radio interference, audible noise, production of ozone. What is the Ferranti effect? The Ferranti effect is the phenomenon in which the receiving end voltage becomes higher than the sending end voltage under light load or no load conditions in long transmission lines. This occurs because of the charging current flowing through the line capacitance. What is surge impedance loading SIL? Surge impedance loading SIL is the loading at which the reactive power generated by the transmission line capacitance equals the reactive power absorbed by its inductance. Interpretation: load greater than SIL implies line absorbs reactive power. Load less than SIL implies line generates reactive power. SIL is an important parameter in EHV and UHV transmission systems. What is the difference between transmission and distribution systems? The power system has two main parts: transmission and distribution. The transmission system carries electricity over long distances at high voltages, typically 132 kilovolts and above, from generating stations to substations using transmission towers. The distribution system then delivers electricity at lower voltages, 33 kilovolts and below, from substations to homes, industries, and other consumers through poles and distribution transformers. Why is HVDC transmission preferred for very long distances? HVDC transmission is preferred for very long distances because it has lower transmission losses, eliminates reactive power issues, does not suffer from the skin effect, provides better stability, requires only two conductors, is economical for long-distance bulk power transfer and submarine cables. What is the difference between stranded conductors and bundle conductors? Stranded conductors are made of many twisted strands, providing excellent mechanical flexibility and are widely used from low to high voltage systems. Bundle conductors, however, consist of two or more parallel subconductors and are mainly used in extra high voltage transmission lines to reduce corona loss and improve electrical performance, although they are more expensive.